Welcome, this is 5.6, switching between forms. So we've talked about all three forms now. We have standard, intercept, and vertex form, okay, and they're listed here below, above their names or below their names. But now we want to be able to figure out how to switch between forms, because sometimes graphing is a lot easier if you have it in a certain form, okay? So this is the flow chart. Okay, if you want to go from standard form to intercept form, we've talked about this already. I think that was in 5.4 when we learned about intercept form. We switch by factoring. Okay, so we'll do glasses. You may need to take out the GCF first. Okay, if you want to go from intercept form back to standard form, you just distribute, you FOIL, or we use a box method. Okay. If you want to go from standard form to vertex form, you need to complete the square. So we get it, we don't solve by completing the square, we just put it into, in that form by completing the square. And we'll talk about that. And then vertex form back to standard, all you have to do is distribute. Okay, so let's do some examples. Let's do B. All right, so what form is that? Okay, you may want to pause and see if you can do this by yourself. Okay, this would be intercept form. Oops, sorry, my bad. So we have y equals x minus 4 times x plus 6. Okay, and we want to switch it into the other two forms. Okay, so if we follow our flow chart, intercept form, the only thing we can do from there is to go to standard form. So here we'd need to distribute, FOIL, box method, whatever you'd like to do. Okay, so here I'll FOIL. That would give us x squared plus 6x minus 4x and minus 24. Okay, and all we have to do after that is combine like terms. So y equals x squared plus 2x minus 24. Okay, not too bad. So I guess that should be over here in standard form. Now we want to switch it from standard form to vertex form. So how we're going to do that is I'm just going to rewrite this here. Okay, to keep it the same of how we did it before, when we were solving, we would set that equal to 0. So 2x minus 24 equals to 0. And then we solved. Okay, but we're not going to solve all the way. I'll show you where to stop. Okay, so we're going to do the same steps. In unit 4, we would add 24 to both sides. Would leave a spot to complete the square. Okay, what completes the square is always b over 2 squared. So in this situation, b is 2. 2 over 2 is 1, and then you square that, it gives you 1. So we would just add 1 to both sides. Okay? And then after that, on the left side, we can write that as a perfect square. That would be x, or a binomial squared. That would give us x plus 1 squared. So remember, it's half of b. And then would get 25. All right, and in the past, from there we would solve by square rooting both sides, and then we'd subtract 1 to both sides. But we're not solving. But I mean, if you wanted to find the x-intercepts, yes, you could do that fairly easily. But what we're going to do is we are going to subtract it back to the other side. So we'd have x plus 1 squared minus 25. And then we're going to put the y back. So we'll have y equals. And that will give us in vertex form. Okay? All right. So let's try another one. What form is C? Well, that's in standard form. Okay, I'm just going to put an arrow down saying that's where it's at. And then we want to write it in intercept and vertex form. So looking at our flow chart, we could go either way. We can go from standard to vertex, or we could go standard to intercept. Okay, so let's just do an insert intercept first. So we would do glasses. That gives us 15x squared, adds up to give us negative 8x. Okay, so what would make that work? Probably 3 and 5. So minus 3x and a negative 5x. Okay, since a is 1, okay, the coefficient in front of x squared is 1, we can use the shortcut. So we'd have y equals x minus 3 and x minus 5. Okay, make sure we do not change those signs when we're solving. Okay, but if you wanted to find the x-intercepts, again, we set those equal to 0 and would solve for x, and that would change its sign for the x-intercepts. Okay, and then vertex form, again, same sort of thing, x squared minus 8x plus 15. Okay, to make it like we did it before, we'll just set it equal to 0. We'd subtract 15 to both sides, so we'd get x squared minus 8x equals negative 15. And then to complete the square, c equals negative 8 over 2, which is negative 4. Square that, gives you 16. So then we would add 16 to both sides. You can write it as a binomial squared. Remember, it's half of b, so that would give us minus 4. And then here we would have 1. Now we subtract 1 back to the other side, and we end up getting y equals x minus 4 squared minus 1. Okay, and then let's do one more because we haven't done one from vertex, going back from vertex form to standard. Okay, so we have our vertex. Put an arrow over there for vertex form. The next thing we can do is put it into standard form. Okay, so to put it in standard form, again, we just distribute, right? Just remember that something squared is the same as multiplying itself that many times. So we cannot distribute. That would give us a wrong answer. So we need to rewrite it as x minus 2 times x minus 2, and then we'd still have our minus 9. And then we would distribute. So that would give us x squared minus 2x minus 2x, and then negative 2 times negative 2 gives you a plus 4, and then we have our minus 9. So those are like terms, those are like terms. So we'd have y equals x squared minus 4x minus 5. Okay, now we have it in standard form. We could do intercept form. So if we do glasses, that gives us negative 5x squared and adds up to give us a negative 4x. So maybe something like negative 5x plus x. Okay, and that would work. And since a is 1, we can use the shortcut. We get y equals x minus 5 and x plus 1. Okay. The other ones that we haven't covered are basically the same, except we have an a value that's not 1. So you'll just need to, for like these ones, you just, here we'd still need to distribute, write it as like 2x plus 1 times x plus 1 plus 4. And then we'd need to FOIL, and then after that we'd have to distribute the 2. But if you have any questions on that, I feel like that's something you could probably come up with. So let me know if you have any questions, and we'll see you later.